Okay, so let's look at some example problems here related to the types of radioactive decay. If we look at our first one, we have 59 over 27 CO plus 0 over negative 1E. So right here, this right here is the only type of radioactive decay that has something else in the beginning of the reaction. And this one would be electron capture. What makes this electron capture? Well, a couple of things. First of all, you notice right here, the part that I've circled that represents an electron. You have the negative 1 with the E there, and it has 0 mass, because we know electrons do not have a mass. So that makes sense as far as it being electron. And the electron is being added to the nucleus. You'll notice we went from 27 protons to 26 protons. And that's what happens in electron capture. The atomic number decreases because when the electron gets captured into the nucleus, it goes towards the proton and combines with the proton, and then the proton is going to become a neutron, and therefore our mass number does not change. Okay, so that mass number remains the same. So this one is a great example of electron capture. The biggest thing to notice is that you have cobalt plus the electron. So this is the only one in which there's something being added right at the beginning. If we look at the next example, we have cesium becomes iodine plus 4,2 over He. So right here, that is the alpha particle. So we know that this one must be alpha decay. So because this is alpha decay, a couple of things. In alpha decay, that's the only one out of all the 4 types that we're looking at in which the mass number changes. It went down by 2. Because in alpha decay, what happens is you have 2 protons and 2 neutrons leave the nucleus. So if you look, we went from 133 to 129. So we decreased the mass number by 4. Then our atomic number also decreased by 2. So it went from 55 to 53 because we lost the 2 protons. So if we look at our math here too, we can always check. We have 133 over here. 129 plus 4 equals 133. So the mass before and after remain the same. And then we have the 55 here, which is equal to 53 plus 2. So that mass also remain the same or the protons remain the same on both sides. So the key to identifying alpha decay, you'll notice that the helium nucleus is being emitted. Looking at our next example here, one of the key things to pick out right away, we see this particle right here. This represents a positron. So this is positron emission. Positron starts with a P, positive 1 right here. So that's a great example of positron emission. That's what you're going to be looking for. Looking at the other thing. So what happens in positron emission? Positron emission, the proton, which is positive, gets rid of its positive charge and becomes a neutron. So looking right here, we have 38 over 18, and now we have 38 over 17. So we've lost a proton, and it turns into a neutron because remember, our mass number remains the same. If we had 38 over 18, that means we have 18 protons and we had 20 neutrons. Now, if we look over here, we had 21 neutrons and 17 protons. Both of those equal 38. So that is positron emission. Big thing here, you see that positive 1 right there. Another example, looking at this one, we see this negative 1E. So you're like, okay, well, it could be a beta particle. Is it electron capture? Is it beta decay? Well, what else is going on? If you notice, we increased our atomic number. We went from 67 to 68. This is the only type of radioactive decay in which the atomic number actually goes up. In all these other ones, 27 to 26, the atomic number went down. 55 to 53, the atomic number went down. 18 to 17, the atomic number went down. But in beta decay, the atomic number actually goes up. Because remember, what happens is that the neutron emits the beta particle, which has that negative charge on there, and the neutron becomes a proton. So looking right here, we had 67 as our number of protons, and now we have 68 as the number of protons. So our proton number went up. The mass number remains the same because we're just switching the neutron to a proton. That's it. Okay. So this one would be our beta decay. So key things about each of these, we have the electron capture right here. We notice this is the only one that has two things in the beginning, okay, CO plus the electron. The thing to pick up for alpha decay, you'll notice that helium nucleus, the 4/2 He, also the mass number changes. Alpha decay is the only one in which the mass number changes. And then we have the positron emission, and for positron emission, that's the only one with that positive charge on there, the positron. And then finally in beta decay, that's the only one in which the atomic number actually goes up from 67 to 68 in this example. So all the other ones, the atomic numbers go down. So those are some examples of each of the different types of radioactive decay.